So the previous part we have been working on. Any questions about these exercises? I want to finish this before we move on, because today we have to talk about volumes for two defining functions. In other words, rotational objects with holes in them.
Yeah, we have
So questions about the previous paper before we go on?
the fourth one.
The first.
Four.
And number 4, find an expression for the volume of the cone. All right.
In the peak.
Sorry, just a moment. Something happened. Okay. All right. So, number 4. We have this straight line intersecting the y-axis at the point R and the x-axis at the point H. And when this area revolves around the x-axis, obviously we get a cone. I think you recognize that we get a cone. We get a cone. So we should, first of all, we need an equation for that line, and then we will integrate this line, obviously the square of the function times pi from 0 to h. Alright, so the difficult part possibly, well the only difficult part really is algebra, because it has no numbers but only r and h, which are constants. Alright, so the gradient of a line, remember, is the difference of y coordinate divided by the difference of x coordinate. So the difference between these 2 points, the y difference is minus r, the x difference is h, minus r over h. And that's the gradient of this line. That's the gradient of this line. Because when we move h units along the x-axis, the y value decreases by r. So this is the gradient. And now, because it's a straight line, obviously the function will be y equals gradient times x plus the y-intercept, which is obviously the point r. So this is the function. That's the first difficult part. If you had numbers, probably you could count the squares and write it number-wise. But because we have parameters expressed in variables and in letters, it might seem difficult, it might seem more difficult. Alright, now, to find the volume of this, we have to integrate pi times minus r over h x plus r squared dx pi from 0 to h in this segment, from 0 to h. And what we have to remember is that r and h are constants, and x is the only variable here. Of course, to integrate, first of all, again, it's very easy to make a mistake. You have to square this. Remember the square of the binomial. So it's r squared over h squared times x squared minus 2 times the product, so minus 2 r squared over h times x plus r squared. This is the final function that we have to integrate. I simply squared what I have there. And it's difficult probably because you have no numbers. Otherwise, it's a very basic thing. In the test about definite integrals, I believe I might give you the function with numbers and ask you to find the volume of that specific cone or frustum or something. Now all we have to do is integrate. So x squared integrated is x cubed over 3. So we have r squared x cubed over 3h squared minus 2x integrated is x squared. So we have r squared x squared over h plus, this is a constant, so the primitive function will be r squared times x from 0 to h. Now, obviously, if I put 0 for x, these terms all will be equal to 0, so all that matters is the h value. Okay, pi times r squared h cubed over 3h squared minus r squared h squared over h plus r squared h minus 0, 0, 0. That's it. Now simplify this, take them all together. Notice that h squared and h, when cancelling out, these two terms disappear because they are the same, rather opposite.
And cube those, no? The cube?
So we will have, yes, it will be simplified. So we will have pi, we will have r squared, we will have simply h, and we will have 1/3 of all that. And that's the classical formula for the volume of a cone. This is what we remember, what I remember from geometry. The volume of a cone. This is how we obtain the formula for the volume of a cone. So the first difficult part was generate the equation for the line so that we have something to integrate, square it correctly, open the brackets, then integrate it, keeping in mind that r and h are constants and they simply stay there, and we only look at x for integration. And then put in the boundaries, h and 0, and simplify. So it's more algebra than calculus. More algebra in the sense that you have to do algebraic manipulations more than actual calculus. Integration is this. That's all. More questions?
And about the fifth one, what did you take the interval
the
from
sphere.
0 to
Okay.
r?
Okay. I had one person very confused because they got half of what we needed, and the problem was because this person took only this part from 0 to r. But of course, to get the full sphere, we would need from minus r to r, or we could take from 0 to r and double the integral. Okay, so remember, x squared plus y squared equals r squared, which means y squared is r squared minus x squared. I don't have to find the square root, because afterwards I will need to square it again for the volume, so no need. So the volume for this is pi 0 to r, and then I write double this, because I will only let this part rotate and get half a sphere, so obviously I need to double to get the volume, so I double that. And so y squared, the function squared, is r squared minus x squared dx. I could write y equals square root of this difference, but then afterwards here I need to square it again, so why bother? So 2 pi 0 r squared x minus x squared over
X cube.
yeah, no need for the integral line. R squared x minus x cubed over 3 from 0 to r. Again the same thing. If I put 0 in x, nothing happens. I have 0 terms, so all that matters is this r value. So it's 2 pi times r cubed minus r cubed over 3, which is 2/3 of r cubed. So it's 2 pi times 2/3 r cubed, which is 4 over 3 pi r cubed, which is again the classical formula for the volume of a sphere. And that's it. So you see, it's not that difficult. All you have to do is to realize what to do and to understand how it connects with this case. The difficult part is probably that, no, you do have a sketch. Okay. Then there's no difficult part there.
Can you solve for 7b?
7b. Yeah, sure.
Yeah, there was no answer.
There was no for 7 probably. I didn't put the answers there. Oh, I'm sorry. I have answers but somewhere else for number 7. Alright. 7, which B? Cosine of 2x?
In C, I got 0.
In C.
Yes.
You got 0. What?
0.
Is that possible?
No.
Which one? C?
Should be 1, should be pi.
In C you cannot get 0.
1 should be pi with pi.
In C you cannot get 0. Because remember the sinusoid is like this. From 0 to pi. So the square root would obviously be something like this. And you cannot get 0 when it rotates.
But
It's still a definite volume.
we get an integral of sine, so it
Yes,
will be
yes,
minus
yes,
sine.
yes. We get the integral pi times sine x, square root of sine squared,
Yeah.
Yep.
0 to pi dx. Alright, so it's pi times the integral of sine is minus cosine x from 0 to pi, which means it's pi times. Cosine of pi is what? Minus 1. So minus cosine of pi minus minus 1 is 1. Minus cosine of 0 is 1. We have to subtract minus, so minus cosine, another minus sign. So it will be actually 2 pi. It will be actually 2 pi. I think you got confused in this because the value of cosine 0 is 1. This is minus cosine function, so it's minus 1, and then you have to subtract this minus cosine. That's why. That's probably the reason for problems. Any other problems with 7? 7D would give you 1 over cosine squared. From that you would have the integral tangent. For cosine or for cosine 2x, cosine x or cosine 2x, you have to integrate the square cosine, for example, of 2x squared pi from 0 to pi over 4. That's B. Cosine squared. Remember that you cannot integrate a square of cosine or a square of sine directly. For that we needed some trigonometry. Remember that cosine squared alpha can be expressed as 1 plus cosine double alpha over 2, and sine squared of alpha is 1 minus cosine double alpha over 2. So if you apply these formulas for decreasing the power, simplifying this thing, then it becomes simpler. So 0 pi half, so that would be 1 plus cosine of double angle becomes cosine 4x over 2 dx. So we can take pi half now outside, and here we have now 1 integrated is simply x, plus cosine integrated is sine of 4x, but because it's 4, you have to divide by 4. I hope you haven't completely forgotten the methods of integration on basic integrals. 0 pi, sorry, it was fourth. Pi fourth. So now we see it's pi half times pi 4, that would be pi squared over 8. Plus now pi over 4 times 4 is pi, sine of pi is 0, so that would be 0. Minus 0 instead of x times pi half is 0, and minus sine of 0 is still 0, so more 0. So the final answer is pi squared over 8. Or we could do it like this. Okay. Then at least it's clear what's going on there. Pi squared over 8 is the volume. So whenever you see cosine squared or sine squared, remember this. It's important. It's important because otherwise you will find it very difficult to integrate, if not impossible. We always try to lower the power to make it less. All right, more questions about this page? No. All right, so we can move on. Finally. Sometimes it just happens that the area that revolves around the x-axis is not the area below a function, but perhaps the area between two functions. For example, this area from A to B between these two. So the upper function f of x, the lower function g of x. And if this revolves around the x-axis, we get something like this. An object with a hole inside. An object with a hole inside, so it wouldn't work as a dish or any vessel because nothing could stay inside, although sometimes it's possible that the situation is more complicated. For instance, it could be something like this and the hole is like this and then it rotates, and so here it is full and solid and then somewhere there the hole starts inside. So it's possible to have something like this, but then you would have to split it into two parts or find the total volume and then find the volume to subtract. In general, that's what we do normally here. So we might find the total volume obtained by revolving the total area below the graph of the function f, and then cut out the whole by subtracting the volume obtained by revolving the area below the function g, normally. So we could imagine that, first of all, we get a complete solid object without holes, so we take only the area below the function f. That would be pi from a to b integral f squared of x dx. That's the outer volume. And then now let us cut out the hole. Let us subtract the volume obtained by revolving, get some other color, by revolving this area. So we are cutting out this hole. So subtract pi from a to b function g squared x dx. And of course, because of the properties of definite integrals, we can combine these two in one integral. So written as a single integral, it looks like f squared of x minus g squared of x integrated by dx. That's it. That's all. Please note one thing. You cannot subtract first and then square it. Remember that for finding the area, it was okay. We subtracted these two functions and we integrated to find this area. But for the volume of revolution, it's different. You get something different when you revolve this larger area and then cut out the smaller area from the volume. Different from as if you had this moved down and had only this area expressed by the difference, this area revolving around the x-axis. So it's completely different because it's physically different. You have to be very careful with this because I know people are tempted to subtract first, square afterwards. No, sorry, that doesn't work. You have, because of the way we obtained this formula, the way we looked at this, it's clear that square minus square, the difference of two squares is the only thing that works. If you try to subtract and then square, you get a completely different formula. You get something completely different. If it makes things simpler for you, of course you can factorize this f plus g times f minus g if you like, but I don't see much point. I don't see much point unless the functions are such that something cancels out nicely. That's possible. So that's about it. That's about it for the new topic, and now I would like you to do 1, 2, 3 only for exercises, simple ones. And then let's see. We have a lot of time, so we might perhaps, after these 4 exercises, we might perhaps start something new. Something new. Displacement, velocity, acceleration, physics. But very simple physics. I would say primitive physics. Okay. I think I emailed this file to you all in a single file, because this is page 3, probably for defining functions. And I also believe
You sent it already?
Yeah, so let me check.
No.
I will check. But I think, wake up.
You have sent the answers for sure. It was in the first.
Yeah, I did. Okay.
The answers, yeah.
Yeah.
In the first email.
But the thing is that this is all in a single file on my computer. I didn't split it into 2 files. I only chose to split it into 2 papers, but it's the single file. So you should have the answers.
Exercise 2.
You should have.
Oh, yes,
Yeah.
yes.
Hey, somebody wants vectors. Hello.
This is the second email I wrote. The first one I think went into first
I'll check. I think it was vectors. I think it was vectors only.
Yes.
I remember there was only 1 topic remaining.
Yeah. I need to start sometime. That's it? You're not going to explain anything?
Yes, but because this is finished, yes.